Welcome to my talk about our project iFAR, which stands for Interactive Full-Size AR. In particular, I want to talk about our work in progress we call mobileAR for cultural heritage. Here we see a picture of some remaining parts of the castle in GRAZ. This is in Styria. I always wondered how it looked like 150 years ago. You can see a plan on the right side showing the abandoned buildings that existed exactly where today politicians park their cars. Often it is hard or even impossible to imagine what a historic site looked like in the past. Such an experience would be immensely helpful in conveying the importance of historical events or helping one to develop an opinion concerning urban planning decisions. In order to achieve such experiences, usually interactive PC applications or virtual reality experiences are developed, but both have severe limitations like the inability of exploring such a situation on site or together with other participants. With our approach, we will develop an application for mobile devices, like smartphones or tablets, to look through an AR window into the past or into a possible future. Interested individuals will be able to use it while walking around on a large site and be able to interact with non-player characters as well as avatars of other participants. They should be able to look at non-existent objects, buildings, and other environments from different angles. Additionally, they should be able to interact with them or even change them. Let me try to define AR and VR. In 1994, Milgram and Kishino defined the virtuality continuum as the span between a real environment and a virtual environment. Everything between these two poles was called mixed reality. In this definition, augmented reality enhances and extends reality without replacing it completely. As the term was defined differently by several companies in the last years, its usage frequently leads to confusion. Phony and others therefore introduced a 4D coordinate system to categorize different approaches. The axes describe the interactivity, automatism, precision and visual consistency, and the degree of virtuality. While there is no generally accepted term for the type of technology we intend to use, we will use mobile augmented reality or mobileAR in the following to describe a partial overlay of the real image with computer-generated, preferably three-dimensional objects, depending on location and position, using a smartphone or a similar mobile device. There are several questions that have to be tackled before implementing such a system in a cultural heritage site or museum. One field of research is the accuracy and reliability of inside-out tracking methods, as provided by mobile phones equipped with ARKit or AR Toolkit. The question is how well these techniques work in situations where many moving objects like cars and other visitors are interfering. Additionally, it has to be researched if it is possible to display the other participants on the AR screen of a mobile device convincingly and accurately as avatars, and to adapt the user's movement and gestures to the avatar. In VR and AR, social interaction is expected to bring added value to the user's experience. Social applications like VR chat are already widespread for VR devices. Interaction with non-player characters like der sprechende Kälte and playful elements like in the Neanderthal app have been combined with location-based AR applications. Let me now describe our application. With the help of mobile devices capable of using SLAM, it has become possible to offer a window into a virtual or past reality with tablets and mobile phones. With this method, visitors can be offered a look into the past. We designed a mobile AR application for Android and iOS smartphones that can show the demolished parts of the castle by looking through the device like a window. It is possible to walk around the whole site and look at the buildings from all sides. The GRAZ castle was chosen as the content of the prototype because it is historically interesting, and due to the partial destruction in the 19th century, it seems to be a perfect example of how historical buildings can be made visible again. The Castle of Graz was recognized as a World Heritage Site by UNESCO in 1999. Parts of the castle even go back to the 14th century. Large parts of the castle were demolished in 1853 and only parts were preserved. Parts like the early Renaissance portal leading to the inner courtyard, a work of Domenico del Alio, have been abandoned. We are using Unity as developing platform, AR Foundation as a platform-independent library to implement AR functionality, and Photon Engine to implement multi-user tracking and real-time interaction in AR. The users join a so-called room and can move themselves and the smartphone and look through the screen into another time. There they can see abandoned buildings in place, occluding the image of existing objects. The players can interact with objects in the scene, for example, view, push or collect them by focusing or touching. In this view, they can also see the avatars of others who are currently in the same room. The other players are represented by avatars located exactly where the real users are. The other participants are integrated into the AR storytelling as historically dressed avatars. One can interact with others and is forced to work together with them to perform certain tasks and unlock achievements. It is possible to chat with these persons via a chat function, either privately or in a common chat room which is visible to all users in the room. Non-player characters can appear and talk to the players, so headphones are recommended, and tell them about the historical events and assign tasks to them which have then to be solved either alone or in collaboration with other persons in the room. It is possible to combine these tasks with other locations where similar applications were provided. As you have seen, not all features were shown in the video. This is partly due to the organizational restrictions we had in the last weeks. At the moment, our prototype is capable of showing the castle, switching between times, and recalibrating itself. Other users are already shown as avatars, similar to what you have seen in the video. Above the heads, an icon shows if they are communicating with you, and you can touch them on the screen to send a message. Also, it is possible to place simple objects in the scene, and these objects are seen and manipulated by the other participants. Non-player characters are already available. The long-term goal of our research activities is to assess the usability of mobileAR using SLAM with user-owned devices, so-called bring your own device. Another point to be investigated is how we can improve the experience by adapting the image on the screen to the real vision of the user. By using personal devices, we try to avoid the obstacles that teachers and museums usually face, like the prohibitive acquisition costs of devices, maintenance, insurance, and much more. Compared to VR devices, we can eliminate the need for cables, high-end computers, and tracking devices. In addition, we create the possibility of interacting with other participants, walking around and exploring everything from different angles. An important point to investigate in the future will be how to improve the immersion in mobileAR. As you have seen, there is a difference between the shown image and the real image. This is due to the fact that the AR software expects the user's face exactly in a predefined distance perpendicular to the screen. We intend to search solutions to this problem in the next year. Also, we will especially look at the impact for sensitizing visitors to historical content and the importance of dealing responsibly with historical buildings and ensembles. The social interaction and the acceptance of the activities have to be tested along with the technical restrictions and the accuracy of the tracking. In addition to the visualization of the historical buildings at a predefined historical date, we introduce and test activities to improve the emotional connection with history and the understanding of the processes. Based on the results, solutions for simple design of such applications, conclusions about acceptance and sustainability, and other areas of application such as urban planning and tourism shall be described. Hopefully, we can contribute to a future where AR applications can help students understand the importance of historical events as well as enable urban planners to better present and discuss their visions to those involved on-site and in full scale. Thank you for your attention.